recording. Welcome to the Dapper community call this fine October day, October 27th. As always, you can find recordings, more details on those community calls at this link or on the community repo for Dapper. This time around, we have a few interesting stuff we're excited to talk to you about. We're going to start with Russell from Ignition Group, who's going to show us a real world scenario where he is using Dapper. Then Sharon's going to give some updates on performance benchmark numbers. Archer is going to show us a cool way of running Dapper on a Raspberry Pi. And Aaron and I will give a quick overview of the recent docs experience that we just launched. As always, we have time we're going to leave some time for open Q&A, but really feel free to drop any questions in the chat, especially as we kind of move between sections of this call. We'll try to address them. Also, feel free to raise your hand if you want to be unmuted and ask the question directly. So with that, let me kick it over to Russell. Go ahead, Russell.
Okay. Hi, guys. Let me just get my screen up. There we go. So I'm from Ignition Group, which is a digital marketing organization based over here in South Africa. And I'm the Chief Digital Transformation Officer for Ignition Group. We've been working with Dapper for quite a little time now, and we have a number of aspects in production, which is very exciting. And we're starting to roll out quite a lot more all the time. We're making quite an effort to contribute to the open source world for the bits and pieces of the infrastructure that we've built that aren't entirely proprietary to Ignition Group. And one of the pieces that we use a lot is a port of Windows Workflow Foundation to have an enterprise workflow engine within our Dapper environment. So what I've got here is just an overview architecture of how the whole kind of workflow system fits together and how we make use of Dapper while we're using it. So obviously we had to use a port of Windows Workflow Foundation because everything we do is using .NET Core, and the Windows Workflow Foundation is only based on .NET Framework. So we used our starting point was the UiPath port, and we've made various modifications to that so it runs nicely in the Dapper Kubernetes environment. So we run Dapper in Kubernetes and AKS in Azure, like we do everything. Just working through the architecture here. So the point of entry is this Dapper binding, where any parts of our system that want to run a workflow put a JSON request into in our case, we use a queue, but obviously it could be anything that a Dapper binding connects to. And then we have that feeds into a workflow service, which is a Dapper microservice that's bound to that binding, and it then demultiplexes that request and decides what to do with it. Then we have a scheme of actors that actually model the workflow that we are trying to execute. The reason for doing that is that when you create the workflow, the workflow service just creates an instance for you, and that has a GUID, which doesn't represent anything in the real world. So, for example, if we are running a workflow that's modeling a customer order, then the actor maps between the order ID and the workflow instance that's going to process the actual order. And so we use the Redis instance store, which is part of the Dapper framework, and that really works quite nicely. So thereafter, you can refer to the instance of the workflow just by the order ID, and we have a different actor type for all the different type of real world entities that we are kind of operating the workflows on behalf of. Then we have our workflow service, which is another Dapper microservice that's hosting the workflow runtime, which takes the definition of the workflow from an Azure blob store and executes it for us. Over time, the workflow will hibernate, and that gets pushed into an instance store, which again is a blob store in Azure. So everything's based in there. We have another interesting facet that we're going to show today as well, which is a human workflow aspect that we've added to Workflow Foundation, because we're very much based around trying to do straight through processing. Errors happen and that kind of thing, and we need human intervention at times. So we've built quite a sophisticated human task pattern as a kind of add-on to Workflow Foundation. So then we have 3 UIs over on the right here. So first of all, the entry point is really the workflow editor, and that's a Windows application that hosts the editor for letting you visually build the workflows. And it's got a few functions there that I'll show you, but the definitions of the workflow then just end up in this blob store, and then that's available to use. The workflow editor lets you manage all the versioning of workflows automatically and lets you designate which latest versions of workflows can be published as well. So, and we think that works really nicely, and it's a big addition, I think, to the Workflow Foundation system. Then we have a tool that we call Patrol, and that's the user interface that humans go into to see what's going on inside the human tasks in workflows that are running. And finally, we have an instance manager, which is the kind of thing for operational staff to go and use and just check on all the running instances and sees what's actually happening from a technical basis. What I can show you now is the actual workflow editing tool. So this is a hosted version of the Windows Workflow Foundation editor. And importantly, what you can see here in this section on the bottom left is we've got custom activities that represent all the microservices in our Dapper cluster that are available to use. So what that means is having all the services that we've got on what we term the microservice backplane can now be used by business users in our enterprise and orchestrated without having to come back to development to actually use, which is really our target here. So we're really trying to build a low code or no code environment so that we can really turn around things very, very quickly and get them into production. So if I just drop onto this design service here, this microservice, you'll kind of see how that works. So in the bottom right-hand corner here, you can see we've got the Dapper ID of the service. This particular method is going to take a post, and the request route is really the service endpoint on the controller inside the Dapper service, and we can get the result of the service into an expression, so we can use what's happened in the microservice anywhere else in the workflow. And as per the kind of the standard Windows Workflow Foundation, you've got the variables you can create and arguments and all the various imports you can use. So all that stuff is all still fully available. So what I can show you now is this portion of the UI on the right-hand side here. You can see all the workflows that are available to execute or actually edit, and you can just do that in here. So if I open up that particular workflow, which is one we've actually got in production, what you'll see here is a load of sequences, And then eventually at this stage, we can drill into something that's actually using a bunch of microservices to execute some business functionality. Then if I go into this thing here, which is a human task, which I think is one of the powerful features we've added. So if there was a failure in the previous microservice, so at this particular point here, we're going to say, okay, that thing failed, what we're going to do about it. So instead of just failing the workflow and dying horribly, we can then go into this human task facility. And in this particular case here on the right-hand side, we're offering 3 options to the human, either retry, continue, or cancel the order. And the workflow now essentially stops at this stage and waits for a human to tell it one of these 3 things to do. These are all arbitrary. You can do whatever you want at this stage. So if I now just go back to the my UI, so this is our patrol user interface. So these are all the human tasks. So these are potential failures in the workflow. And so an operator can go into any one of those. They get presented with all the details of the thing that kicked off the service, and they get the output of the service that caused the problem. And now the operator can choose these functions. So potentially they can go and fix some data in another system and click retry. They can just say, this is never going to work, and they can cancel it. Or they can say, do you know what? I don't care about this error. Please just continue and carry on. So this really gives us an opportunity in the business to really solve a lot of the problems. Previously, we were picking up errors in our processes and having to handle them in service ops, and we had a whole bunch of people sorting this out. But now using these tools built around the microservices, we can reorchestrate services and update things in minutes that used to take us potentially days or weeks to do. And because we've kind of got some automated process around building new microservices, typically we can get a microservice into production in a day if we have to. It can appear straight away in this tool, and then you can just start to use that new microservice pretty well immediately. So it's made a big change to the way we operate the business. Really taking full advantage of all the facilities in the very easy way that you can access microservices just by simple wrapper classes in here. This whole code base that we've got here, kind of from end to end, we're making available in our GitHub repo, which I can post into the chat now for those that you are interested. We'll have some documentation available in here and tell you how to kind of hook all this up, but over and above any, so it means that you can now use any Dapper microservice and orchestrate that in a workflow that's already hosted in Dapper. So for us, it really brings the whole piece together. We'll also be making available in this repo the wrapper we have to the Commander business rules engine that we make a lot of use of as well. And again, you can build business rules in a GUI and operate those business rules within inside the workflow. So again, it really drives us down to a very low code or no code environment, so that our business analysts or business users can make quite significant changes, but in a controlled fashion, to all of our business processes without ever coming back to dev. So we're really excited that we've got this in production already, and we'd love to see what other people are going to do with this once it's published. and we'd love to get feedback and see what other features we can add to take this forward.
Fantastic. Thank you, Russell.
Pleasure.
I've seen in the architecture diagram that you showed, you're using Dapr actors, you're using bindings, you're using Redis for state. What other Dapr capabilities people can find in there?
So we also use the Dapr secret stores to give us access to hold all our API keys and that sort of thing. But mainly the bindings we use a lot. We use the service discovery is very key to us. We actually expose all our microservices through an Azure application gateway, and we have a kind of a single microservice that we have a lot of replicas of to take all the inbound traffic, and then we expose subsets of those through the Azure API management when we're wanting to expose that functionality to the outside world without giving everybody access to everything that's on the microservice backplane. I think one thing that we're going to start using very soon is the namespace ability that's being added, so that we can kind of separate out all our discrete subsystems. So again, there's less chance of anybody breaking the system because everything's nicely isolated inside the Kubernetes cluster.
Very cool. There was another question from Charlie. Maybe let me unmute you if you want to ask it.
Yeah, sure. You mentioned that you had to use a fork of this workflow service to use to build it on .NET Core.
Yes.
Dapr, would there be any value for your team in not having to maintain that fork? Because Dapr does now support Windows containers. And that's kind of.
Yeah, potentially. But we quite like the Linux containers, and because we run lots of other services in there as well.
Right.
So it kind of meets our needs. So all of our UIs, like I showed you that Patrol UI is just a single page JavaScript app that we run again in the Kubernetes container, and it speaks just using direct calls to the Dapr backplane. So we have all these node apps running in there as well, and they sit quite nicely on the Linux platform. So we're quite happy with that.
But you now have the power to use both if you want within a single Kubernetes cluster. So.
Oh right, okay. We hadn't thought about doing that.
So, but if you do end up doing that, we'd love to hear about it. That's
oh sure, awesome. Okay, yeah. So I might give that as a job to somebody, yeah, for sure.
Great. Thank you, Russell. And it's great to see that we're also open sourcing it so people can check it out. You're on. Let's turn it over to you for the benchmark updates.
All right, let me share my screen. Thank you, Russell, by the way. That was great to see.
Thanks, Sharon.
All right. Can you see the slide?
Yep.
All right. So for 0.8, for the 0.8 release for Dapr, I think a few months ago we released performance benchmarks. I'm just going to have a small recap here about what we showed and then give an update on the numbers that we have. So what we tested was service invocation, which is really, I think, the most intensive communications route that Dapr has. And we measured the same way that service meshes do, like Eastern Linkerd, we measured the added end-to-end round-trip latency when you're calling from one service to another. And also we measured the CPU utilization of the Dapr sidecars and the memory utilization. And so we used industry standard tools. We used Fortio, which is part of the awesome and great test infrastructure that's used by Istio. We were testing on commodity hardware. So we're taking cloud instances without any special networking enabled, without InfiniBand networks or anything like that, just stuff that people will use in their everyday real world clusters. And then we did this using open tests, meaning everything's open source. You can take those performance tests and run them in your cluster on any Kubernetes distribution that's supported by Dapr. So the baseline was really taking a VM in a Kubernetes cluster, two separate VMs, and running the load test upon one of them, which invokes the other application directly. Now the baseline, it doesn't have Dapr involved, and there's no encryption in here too. It's just raw HTTP from the load test pod to the application pod. For the Dapr test setup, we used Dapr injected into the pods, and we also added mutual TLS. So there is in-transit encryption here. So the test setup that we used was have TLS enabled, we had tracing enabled, we had metrics enabled. All of those things were not enabled on the baseline. And we measured 1,000 requests per second for a single pod with a 1 kilobyte payload for a duration of 30 minutes. And we put a limit on the Dapr sidecars for 0.5 CPU and 256 megabytes of RAM. So the results for 0.8 were 4.1 milliseconds for 90th percentile, which was pretty good. And we had memory utilization for 19 megabytes and CPU of around 0.36 millicores. And those were pretty impressive results. And now we ran the tests again using Dapr 0.11. And what we're seeing here are is very improved latency. So we basically reduced the end-to-end latency from 4.1 milliseconds to 1.58 for the 90th percentile. Memory utilization CPU went up a little bit. That's, by the way, mostly due to the usage of Dapr with tracing and open census. We're making efforts now to switch to open telemetry. So although those new utilization uptakes are not that, I would say, they're not, I would say, so, I lost the word there. Not as impactful as you might think. We are going to release new benchmark tests once we make the change to open telemetry. We're very happy about the 1.5 milliseconds. This is, by the way, end-to-end round latency. So for the test setup, this means the application calls the local Dapr sidecar inside the pod, then the Dapr sidecar calls the other Dapr sidecar over the network, and then the Dapr sidecar for the callee side calls its local app, and then there is round trip latency in there. And unlike the baseline, that actually includes metrics and tracing aggregated inside of the result. So this is pretty good. I'm not gonna name other technologies that act or operate as proxy sidecars, but it sort of puts Dapr ahead of some out there. So that's really good to see. And we are going to add actor-specific performance benchmarks, which is also something that we're working on very hard for the 1.0 RC release. So we will be publishing performance benchmarks for actors, things like how many actors you can actually put inside of a single node, what's the density of actors for a given amount of CPU and memory utilization that you give a pod, the latency it takes to activate an actor. And that's pretty important if you're using actors heavily in your cluster, because you need to know how to do proper capacity planning. So with those results, you can know what sort of cluster setup you need to do for Dapr when running it in production. And we're going to have the same thing for actors. And after 1.0, we're probably going to have more of these coming up for pub sub and state and really all of the other building blocks, basically to show what's the added performance latency that Dapr will take from you. If you were just, calling the state store, or pub sub, or whatever component that you're using directly. So this is it. I think it's pretty exciting, and we'll take any questions now, if there are any. Back to you, Ori.
Thanks, Sharon. I'm not seeing any questions on the chat, but if anybody has any, feel free to drop them in. But we can also answer some questions at the end. So we can move along. And Artur, your turn to show us a cool demo with Raspberry Pi. Artur?
Can you hear me?
Yes, now we can hear you.
Okay,
and see you.
so let me share my screen. Okay, desktop one, share. And can you see this terminal?
Yes.
Okay, so I'll do a quick walkthrough of how I could get the Dapr running on a Raspberry Pi cluster. I'm gonna skip the setup where you flash the Pi image, and have it SSH configured. There are many blog posts explaining how to do that. So I'm gonna skip that part. In this case, we have a Raspberry Pi cluster with 4 nodes running Ubuntu and 64-bit version. And if I do SSH, it's just a passwordless setup, okay? So that's one of the Pis. So that's the bare minimum you need for this to work, okay? And we're gonna be using Ansible. So there is a playbook provided by Rancher that allows you to set up K3s, which is a lightweight implementation of Kubernetes. And we decided to use that for this example. So if I open the inventory file, you can see my cluster here. And you can see that I have 4 nodes, the master node and the other nodes from IP 102 to 104, okay? So this is my basic setup. And I just have to make a small change in the setup where one of the files was referring to a Debian user. And in our case is Ubuntu. So I just have to change this line from Debian to Ubuntu, just because I decided to try this OS instead. And after that, all you do to have Kubernetes running on your cluster is to run the Ansible playbook. And that's as simple as that. And then this will take about a minute. So, so Ansible will use SSH and emit commands on the host over SSH to detect the state and perform changes on all the nodes. So each node is behaving as the expected role defined in the playbook. So Ansible seems to be a very good tool to do this type of provisioning. And you can do this also for a virtual machine. So if you have a VM emulating ARM64, you can definitely have a cluster set up that way, so you don't have to buy any hardware. But that was outside the scope for this demo. We're using real hardware here for this. So this will take a few more seconds. On my last run, it took about a minute. And after that, we're going to be able to show how Dapr will install right out of the box on the ARM64 cluster. So it's doing the weight checks. Okay, file access, no token. Creating the kube configuration. Okay, there's just a few more steps. Bear with me a few more seconds, and then we can have the setup ready. There we go. So that is completed. So our next step now is to copy the kube config file so we can actually try the cluster, okay? So now I have the PyConfig copy. I export this environment variable so I don't mess with my other config file. I just export this environment variable going forward. And if I do kubectl get nodes, you will see I have 4 nodes. And their age is just a few seconds, right? So all the Raspberry Pis are set up with this version of Rancher. So I'm going to skip the dashboard setup at least for Kubernetes, because you can try that out later. There are many ways how to do it. Let's go direct to Dapr. So I'm going to use the Dapr CLI to do this, okay? And Dapr init-k should work just like any other cluster. And the team worked on fixing a few Docker images to support ARM64 for this to be possible. So if you do Dapr status-k, now we are waiting for the containers to be installed. And as you can see, even the dashboard is included here. So the dashboard now also works on ARM64. So some of them are running now. Usually the operator takes a little bit longer. So that will take a few more seconds. Okay, all of them running. Now we're just waiting for them to be healthy. Okay, they're all healthy and all running. So now we can also open the dashboard. So let me open a new terminal window so it doesn't block this CLI. So if I do this, we have localhost 8080 with Dapr. Let me open this on a new window. Give me a second. Oops. Localhost 8080. So Dapr dashboard opens up, okay, just like you would on a normal cluster. Now we'll go back here and we're gonna run one application and I hope it works. I'm not sure because there was a change that was made recently, but let's try. Apply-f deploy node. So this will just run a simple, let me open this up. This is gonna run a simple Nginx image with Dapr sidecar, okay? So it's not gonna actually make any invocation, but just gonna run for us to see how it would work. There are some, we tried one demo here and before, and we noticed that not every image is built for ARM64. So we're gonna take action on fixing those as we find to make sure everything, all the demos and quick starts, they can actually work on ARM64. So okay, get pods. Let me just all. Okay, give me a second. Okay, this is running on a different node. That's why. Give me a second. Let me export the configuration here as well. That's one. Okay. Okay, now it's running Raspberry Pi. So, okay, good. Okay, so now you can see the node app is being created in the Raspberry Pi cluster. Gonna take a few more seconds. And it should also appear on the dashboard once it completes. Okay, it's running. So if I refresh the dashboard, you can see the node is showing up here. The name doesn't show up. There's a fix in the next Dapr dashboard release. They're going to show up the name here. But as you can see, we got the Kubernetes cluster provision on Raspberry Pi, and we could run an application using Dapr Sidecar. Okay, so that's all I have to demo. And if you tried using Dapr with ARM64 and you run into issues, please file bugs. We want to make sure Dapr runs smoothly on ARM64. Thank you.
Thank you, Arthur. That's great. Yeah, I'm not seeing any questions at this point, but again, feel free to drop them in. And with that, we'll do a kind of like a quick overview of something we announced this week we're very excited about, which is the Dapr Docs website. I don't know if you got a chance to see our tweet about it and read the blog post, but feel free to seek those out. This was kind of a lot of work around our docs as we, as Dapr has been growing, more and more docs were coming in, and we got some feedback and also felt it ourselves that kind of trying to find things in there is starting to become a little more difficult because Dapr is becoming so comprehensive, and we are trying to always update the docs and bring more docs in. So this was something that we just did now. I let Aaron run us through the docs experience and kind of show how it looks like and what are the different features we can look at. So over to you, Aaron.
Cool. Let me throw up my screen here. Yeah, so kind of here's an old view of the docs. Here's like the 0.11 tag, which was with our latest release. Everything was in GitHub. You had to like almost do like a depth first search of all of the different folders, and then you got to see like the folder view before the content, which worked great for when we first started the Dapr project, and didn't have a ton of content. But now that it's grown exponentially over the past year, we needed something a little bit better. So yesterday we merged into master a project we've been working on. And so now if you go to github.com/dapr/docs, you'll see the new format. But most importantly, we don't expect users to interface with the actual repo anymore. Instead, we're pointing them to our new URL, docs.dapr.io. And this is a whole new docs experience. It uses Hugo as the static site generator, and then we use the Doxy theme on top of Hugo to generate our docs from the markdown files. So this gives you a couple different things. First, it gives you a left-hand navigation bar, which we can group categories of documentation together. And this auto expands. So as you click on different things like concepts, it expands into the different types of concepts. And same thing with like developing applications. As you start to click on things, they expand into those categories. You'll notice that we changed the structure a little bit. And now we have like concepts, our getting started guides. We have a section for our developers, the documentation that's specific to how to develop with Dapr, from our SDK support to the IDE support to our integrations and middleware. And then we have a section for operators, like more in-depth documentation on our different hosting options, from right now self-hosted in Kubernetes. And once you dig in, you can see like our production guidelines and how to run with hybrid clusters. So a lot to gain over here. Additionally, you'll also get the breadcrumb trail up here on the top. So you can see the path where you are from like building your way from operations to hosting to Kubernetes to hybrid clusters, and you can jump up and down. And for any of the categories, like this folder for Kubernetes, we auto-generate the kind of table of contents. So here are all the different guides inside of like this particular folder. You'll also notice that instead of having one giant how-to folder, which was a collection of every single how-to, we've placed them in the folders where they belong. So for example, how to deploy hybrid Linux, Windows, Kubernetes clusters now is inside of the Kubernetes operations folder instead of just being in a top-level how-to. And then if I go over again to production guidelines, we also get an auto-generated table of contents for this page, which is built off of the different headers. So the H2 cluster capacity requirements gets generated into a clickable thing here. The H3s also become clickable links here, and you can instantly see and keep the context of every step of the docs over here on the right. Another feature which is useful is you can, actually let me start down here. Down here you can see the last time this particular page was modified. And if you click on this link, it'll take you into that specific commit to see, like, here's me merging that last commit here. Additionally, if you notice issues in the documentation, you can click here to create a documentation issue. If you notice an issue on that page. And if you notice a project issue, maybe there's an issue with our project, you can click this. Let me bring this down, which will open up an issue in Dapr. And we're working on the templates for this and getting that to work seamlessly. And same thing, you can also click edit this page and it'll take you directly to this particular page in the repo. So I made it really easy to contribute to the documentation, because as you notice things that need to be added to, changed, updated, we want to make it as seamless as possible to go into there. And then finally, my favorite feature, we've been partnering with a company called Ogolia to make a new search experience. So up here in the top right corner, you'll notice a new search box. And if you type something like service invocation, you'll start noticing it autocomplete, and it'll search for like the reference, the service invocation API reference, the like operations guides concerning, in this case, service invocation, the developing applications building block. And we're working on the weighting and some of the experience on this, but and we're also looking into adding it to the middle here, making it a little bit more pronounced on the page. But you can search for things like Kubernetes and get an instant result on that. And if you click on like deploy and run Dapr and Kubernetes, it'll take you directly to that section. And that I think is, and then we're also doing versioning. So right now, since all the old docs for 0.8, 0.9, 0.10 are in GitHub, if you click on this, it'll take you straight into that tag. But in the future, going forward, every like release candidate 1 and version 1.0 eventually will all be hosted on the site, so you can jump in between the releases for that. And yeah, that's the new docs.dapr.io site. Let us know what you think. Please file issues if you notice anything, file issues if you have ideas or want, and feel free to throw pull requests at it. We'd love to take a look and get your contributions.
Yeah, really hoping everybody finds this useful. One maybe thing to stress here, that this is still Markdown. I mean, it has a little bit more bells and whistles because it is being compiled to a static website. But we made sure to, if you go in the docs to a contributing section, you'll find basically all that you need to know. So it should be pretty easy if you're just like fixing like a typo or a broken link, which I know is a lot of stuff that we're very grateful from the community to get. But also if you want to just provide like a new page or a new how-to, also just keep in mind like the structure that Aaron just mentioned. We do want to kind of try to keep it in order. But aside from that, the little things you need to know about how to make, things show up correctly in the right order, and what are these different maybe meta kind of fields that need to be added. It's all, we kind of documented all of that. So contributing should be pretty straightforward. It is still fairly simple Markdown with maybe a couple of things to know. But yeah, that's it. We're pretty excited about it. I think it's a real upgrade for sure. But yeah, hoping to get your feedback. So with that, I think we can turn to just the Q&A. So any questions anybody has, feel free to ask them. Yeah, so I think I see. So Vasu asks, we're building microservices deploying to AKS. Can I have local Dapr microservices talk to remote microservices? So Vasu, do you want to maybe let me let you unmute you and you can maybe explain the scenario a little bit more.
Hey guys, can you hear me?
Yeah.
Yeah. So again, like I'm a complete newbie. Like, and I just started to look into this project. Seems to be gathering a lot of interest in our company, right? So what I'm trying to do is like we're starting down this path of like building these microservices, right? So we have multiple teams building these different services, and then as we're deploying them into AKS, right? So let's say if I don't want the entire stack on my local workstation, so to speak, right? So if I'm working on, let's say, a service A, and then that needs to talk to service B and C, that's being worked upon by other teams, right? So instead of hosting all of them locally on a sandbox, right? Can I have them deployed and then wire them up like from a development standpoint during the build time, right? Can I consume the services that are deployed in AKS? That's primarily what I'm trying to figure out.
So is the question is, can a service on your local machine talk to a service on the Kubernetes cluster or to some?
Yeah, cluster. Yeah, like how would I from the examples it wasn't clear to me, at least I run a local Dapper service, right? So how do I sort of what would be the endpoint that I need to point to a remote service, right? So that's
Yeah. So in that case, you will need to expose an ingress on your Kubernetes cluster to have like a public endpoint, and then instead of calling localhost, you would be calling that endpoint. And we actually have a bunch of blog posts that were written to show how to do that, that really show you how you can Dapperize an ingress, and then you can expose services publicly. If you don't want to have a public endpoint, you can also use port forwarding for Kubernetes. So you can actually port forward to localhost and then just use localhost without an ingress and without any of that jazz. So that should be possible. If you want more information on this, feel free to mention me or any one of the Dapper maintainers on Gitter. We can help you. We can show you a sample.
Generally, though, we found that you can develop a lot of stuff locally, and unless you're talking about lots and lots of services, hundreds. So developing locally should be pretty straightforward. In that you can run the 10 or 20 services you need locally that your app depends on, and then deploy inside Kubernetes or the environment of your choice. So it should be directly possible that everything gets. A key premise of Dapper is that you can develop everything locally, and then without doing any code changes, you just change the deployment files. You can deploy it into Kubernetes environment. So that kind of portability of your code is there. It's not necessarily. It's not necessarily so much that you have you're developing locally one service and connecting it up to all the rest of the services running inside Kubernetes. That's kind of a bit more of a challenge, I would say.
Okay, makes sense. Okay.
So develop everything locally.
Okay, got it. Okay, thanks, guys.
Okay, thank you. Another question. Sorry? Yeah, I see another question from Richard. Let me maybe again.
I think Xavier asked something prior.
Oh, I'm sorry. Xavier, yeah. Docs are looking amazing. Are there any updates on the community chatting tool as well already? So I'm not sure what chatting tool.
I have context, so he means.
Oh, okay, go ahead. You're on.
Yeah, sorry. And you can unmute Xavier so he can speak for himself. But if based on our conversation on Gitter, he probably means Gitter, and if we're the Dapper project is considering moving to Discord or Slack or anything like that.
Yeah, fully correct. Thank you.
Yeah. Yeah, I think we're still exploring it. As we mentioned, we are transitioning to an open governance model where we really want to make sure that all the processes and all the way we're managing and maintaining the project are out in the open, and we create the right kind of channels for people to join and collaborate. So I think we're still assessing that. For now, I think Gitter is is the thing we're using, but we're kind of looking also at other projects. But if you have like preferences or kind of feedback or comments on that, we'd love to hear it. So Xavier, I'm assuming you're asking because maybe you have some opinions on this. So we'd love to hear what you think.
Yeah, no, I do understand the assessment, of course, right? So the thing is just for me personally, but it's again personally, of course, I guess there's some bias everywhere. But I find Git a little bit hard to use. Just in following up, getting more notifications, for example. I find typical tools such as Slack or Discord a little bit more easy to use because you get really notified. Well, it's easy to manage large communities in there. If I then indeed look at the open governance model, I think Discord would be a better fit because of the limitations on Slack, like the 10,000 messages limit and so on. But it's just a suggestion and a request, right? Like, what would the community love to see? Is the community happy with Gitter? Do we stay on that one? Is there a possibility to move it to for example, Discord? It's just an open question.
Yeah, that sounds good. I think maybe, Sharon, I don't know what you think. Maybe we can actually open an issue on the community repo and have some discussions and people chime in over there and see.
I think that's a really good idea. That's what we need to do. Yeah.
Yeah, thank you for that.
Fantastic. Thank you very much.
Great. Okay, so another question from Richard. Is there any plans to enable traffic shifting? Anyway, SMI, I'm guessing the service mesh interface is the, yeah. And as a related question to that, is there a way to bridge Kubernetes and VMs or even just have Dapr act as a gateway for VM-based apps into Kubernetes deployments?
So I presume the first question is about kind of A/B testing type thing, where you want to have part of the traffic go to service A and part of the traffic go to service B. If that's the question, then no, not really. Dapr is not going to try to be a complete service mesh, at least not yet, not at this point in time. I'm sure it might eventually get there, but that's not current plans. But I'm sure maybe in a year's time we might be there and we'll see where we are. But in the current V1 release, that's not a specific goal. For the second one is, can you use it to bridge? Yes, you could. I mean, Dapr is a reverse proxy. You could have it act as a gateway, a gateway service, and use it to forward calls onto other services inside there, depending on, we showed an example for this, like Nginx with Dapr running as a sidecar to it all. We've also shown recently API management running inside of, but that was running inside of Kubernetes clusters. You're asking about running on a VM. So yes, if you have some technology where you want to run Dapr as a sidecar to it and Dapr as a reverse forwarding it, you can do that.
Yeah, I guess the general idea is sound, but I guess I was asking because, especially when talking service invocation, the Dapr and Kubernetes by default uses Kubernetes' own service native capabilities for that. So I was wondering if there was any sort of story around bridging VM, traditional VM apps and Kubernetes-based Dapr.
Yeah, so if you have a Kubernetes Dapr deployment with multiple services and you have a bunch of services running on a VM, as long as you call the Dapr IP not locally, right? So if you're calling from Kubernetes to a VM, you won't be calling localhost. If you'd be calling the any Dapr instance really on that machine that acts as the gateway, that will forward requests to the Dapr services in that environment. If you're asking whether or not you can call Dapr on localhost and have it somehow traffic to a different cluster, that capability is not in yet, although that has come up several times. And if you have design ideas about how we could do that, we would more than welcome that. I think there's an issue open for it as well somewhere.
Okay, I think, Richard, you're muted again if you want to have a follow-up.
I'm very much in the habit of muting and unmuting. Yeah, no, that was the same basic idea because we have traditional IaaS monolith and then we have the microservices. So being able to bridge those two worlds seamlessly is very appealing with us. Unfortunately, I don't have a technical idea because of that exact problem of how do you bridge service invocation across the two worlds.
Great. Well, thank you for the questions. We are just about out of time. Not seeing additional questions, but feel free to drop in Gitter and again, interact with us about anything you saw today or anything at all via Gitter, via the GitHub issues. Yeah, and thank you for joining. This recording will be available on the YouTube channel later today, hopefully, and hope to see all of you in another couple of weeks. So thank you for joining. Goodbye.